Moving on to the next question, we have to sketch the function y equals -2 bracket x minus 4 cubed plus 1 using transformations or mappings. So when we're using transformations or mappings, first thing we have to do is we have to figure out what parent function we're dealing with. And if you look at this function, the parent function is y equals x cubed. So what you want to do is you want to take a table of values for the parent function y equals x cubed. So I'm going to go from -2 to +2 for the x values. So we'll have -8, -1, 0, 1, and 8. And then what you want to do is you want to transform these points with the formula that we know, x over k plus d, ay plus c. So we have to figure out what our transformation values are going to be here. Well, what we can do is we can rewrite this function like that. So notice how there's like this 1 in front that I put, and that's going to represent our k value. So our a value is -2, our k value is 1, our d value is 4, and then our c value is 1. So now what we can do is we can use these transformation values and make formulas for how we're going to transform these coordinates. So our new table, we're going to take all of these x values, divide them by the k, which is 1. So x divided by 1 is just x. So let's just write x here. Plus d, which is 4. And then we're going to have ay plus c. So we're going to have -2y plus 1. So now what we have to do is we have to go down this table for the parent function. For all the x values, we have to just add 4. So -2 plus 4, that would give us +2. -1 plus 4 would give us 3. 0 plus 4, 4. 1 plus 4, 5. And then 2 plus 4 would be 6. And then all the y values, so -2y plus 1, so -2 times -8 gives us 16, plus 1 gives us 17. -1 times -2 is 2, plus 1 would give us 3. 0 times -2 plus 1 would give us 1. 1 times -2 is -2 plus 1 would give us -1. And then 8 times -2 is -16 plus 1 would give us -15. So this here represents the table of values for this function here. And the way we got this table of values was using transformations or mappings with this general transformation formula and our specific transformation values for this function that we are working with. So when we take these points and then plot them on a graph, this is what you'll get, and this is going to be the shape of that function. And notice it's always going to be this shape whenever you're dealing with y equals x cubed, because we know y equals x cubed has the same sort of shape. So it's sort of like that. So whether it's reflected and shifted or stretched, it's always going to take this general shape. And notice how this is that same sort of shape. So we can be pretty confident that we are on the right track with this table of values. Another thing you can do, if you want to check your table of values, is you could test out some of the x values and see if you get the corresponding y values with the function you're given. So for example, if I plug in 2 into the function that we were originally given, 2 minus 4 is -2. -2 to the power of 3 is -8. -8 times -2 is 16, plus 1 would give us 17. And you can test all of these other x values and make sure you get the corresponding y values. And then you can really know that you're on the right track. So you just take that table of values, check it if you have time, and then you just sketch the points and make the graph.